Hi Doctor, my name is Wong Ching Kang, can call me CK. My metric number is A180110. Today, I will do the presentation for the subject BEV20501 Electrical Engineering Lab 1. Experiment at Basic Electrical Simulation using AC source. I'm from Section 9, Group 6. There are 4 group members in our group. The first one is Siti Nurul Jana binti Mut Yatim. The metric number is A190108. The second one is Wangwichi. The metric number is A1900F5. And the third one is me. And the last one is Sufari bin Zulkifli. The metric number is CE210161. And now I will continue to the presentation for the activity 1. Activity 1. The series resistive inductive loop circuit. First, we construct the circuit according to the lecture given. First, we put the AC voltage source. After that, we put the resistor, inductor, and the AC ammeter and AC voltmeter. After that, we connect it. We connect the AC voltage source to the AC ammeter. After that, we connect to the resistor and inductor in series. And last, we connect the AC voltmeter parallel it with the resistor and inductor. And now we set the resistor to the value in the lecture given, which is the 210 ohm, and we set the inductor to the 0.4 Henry, and we set the AC voltage source. Since the AC voltage source given in the lab sheet is 10 watt, and which is the VIMS, so that we need to multiply square root 2, which is 1.4142, which is the V peak, and we set the frequency to the 50 Hz. After that, we set the AC ammeter, the unit to the milliampere, and we run it. After we run it, we record the reading of the AC ammeter and the AC voltmeter into the table 8.1, and we change the value of the load according to the table 8.1, which is we change the 0.4 Henry to the 0.8 Henry. After that, we run again. We also record down the AC ammeter reading and the AC voltmeter reading, and we just repeat the process by change the load according to the table 8.1. That's all for activity 1, and I will continue to the presentation for the activity 2. Activity 2, parallel resistive inductive loop circuit. Since the circuit in the activity 2 is almost the same in the activity 1, but the difference is inductor in activity 2 is connected in the parallel, so that now I will change the circuit. First, I delete the wire between the resistor and inductor, and now I move the AC voltmeter, and now I also move the inductor. And since the inductor has short circuit in DC bias and steady state, so that I need to add a resistor with very small value in the which connect series to the inductor. And now I connect the wire. Okay. As I mentioned, the resistor which series to connect series to the inductor, which is very small, so that I set it to 1 ohm. And the inductor we set it to the 0.4 Henry, and the resistor we set it into the 210 ohm, and the AC voltage source we set to the 10 volt, and the frequency is 50 Hz. Since the voltage given in the lab sheet is the VRMS, so that we need multiply the square root 2 to get the V peak. So after that, and now we can run the simulation, and we wait for a while until we get the stable reading. We'll get the reading of the AC ammeter and the AC voltmeter. We record it into the table 8.2, and we just repeat the procedure by change the inductor to the 0.8 Henry, and after that we run the simulation. We also wait for a while until at the AC ammeter and the AC voltmeter get the stable reading. We record it into the table 8.2, and we just repeat and change the value of the load which mentioned in the table 8.2, and record the reading of the ammeter and voltmeter into the table. That's all my presentation for activity 1 and activity 2, and my friend will continue to do the presentation for the activity 3 and 4. Thank you.
Assalamualaikum Doctor, my name is Siti Nurul Jana, and I will continue with activity 3 and 4. So for activity 3, we use 3 components, which is AC voltage, resistor and capacitor. The connection of RC load is in series. So here is an AC voltage, and then we pick the resistor and the capacitor. Then we connect it with the AC ammeter in milliampere and AC voltmeter in volts. So for the AC voltage, we set to 10 volt times to 1.414 to get the peak voltage. And then the resistor is 390 ohm. And capacitor is 2 microfarad. So now we run the simulation. Then we get 6.16 milliampere for the current and 9.99 volt for the voltage. So next, we change the capacitor value with 4 microfarad and run the simulation. So here we get 11.3 milliampere for the current and 9.99 for the voltage. The emitter reading for the next test already put inside the report. So now we move to the activity 4. So for activity 4, we connect the RC load in parallel. For the AC voltage was same as in activity 3, which is 10 volt times to the 1.414. The resistor is 390 ohm and the capacitor is 2 microfarad. So now we run the simulation. Then we get 26.3 milliampere for the current and 9.99 volt for the voltage. So next, we change the capacitor value with 4 microfarad and then we run the simulation. So here we get 28.5 milliampere for the current and 9.99 volt for the voltage. So the emitter reading for the next test already put inside the report. So that's all from me. Thank you.
A very good day to Doctor. My name is Wamichi. Next, I will continue the explanation for the simulation of Activity 5, which is the series RLC load circuit. In this Activity 5, we are going to conduct for the 7th test, which is the varies of the value in the resistor, inductor, and capacitor that according to the values that have been given in the lecture in Activity 5. And next, we will connect the AC voltage source with the series RLC loads. And this is the component that we will use in this Activity 5, which are the V side for the AC voltage source, resistor, inductor, and capacitor. And next, we will take the V side and we set the part value for the V side to 50 VAC, which is same as the value that we given in the lecture. And for the amplitude, we set the 50 times with 1.4142. We set that the 50 times 1.4142 for the amplitude or the peak voltage. This is due to the given 50 is in the RMS value, and therefore we will times with 1.4142 or the square root 2 to get for the peak voltage. And for the frequency, we will set to 50 Hz. And next, we will take one AC ammeter and we connect it in the series with the AC voltage source, and we set the display range for the ammeters to milliamps. And after that, we will take the resistor and we rotate clockwise, and we set that the resistor to the 390 ohm, which is for the first test in the Activity 5. And we will take the inductor and we also rotate clockwise, and we set the inductor to 0.4 H. And next, we will take one capacitor and we set the capacitor to 2 microfarad. And next, we will connect the resistor, inductor, and capacitor in the series, and we will connect the whole circuit. And after that, we can take a one AC voltmeter and we also connect in the parallel with the series RLC loads. And this AC voltmeter is used to measure the voltage that will flow across the series RLC loads, and this AC ammeter is used to measure the current that will flow through the circuit. And after that, we can run the simulation and we can observe for the current and also the voltage. For the current, we get is 33.3 milliampere, while for the voltage is 50 volt. And next, we can stop the simulation and we can go to the second test by changing the value of the resistor to 470 ohm. And we run the simulation and we observe that the current is 32.8 milliampere and for the voltage is 50 volts. From the simulation, we can see that the voltmeter shows that 50 volts, which is same as the AC voltage source. This is due to the voltmeter is arranged in the parallel with the AC voltage. Therefore, the parallel arrangement means that the voltage will be the same, which is in the 50 volt. And besides that, we also can calculate by using the manual calculation to get for the current and also the voltage. Firstly, we can using the manual calculation to calculate for the total impedance, and next we will using the Ohm's law, which is V equals to IR to get for the I that will flow through the series RLC load. And after the calculation, and we can see that the simulated value and also the calculated value are almost same in the values. And next, we also can repeat the steps and also the procedures to continue for the other tests in the activity 5. Thank you. Next, I will continue the explanation for the activity 6, which is the parallel RLC load circuit. In this activity 6, we are going to conduct and do for the 7th test, which is the values of the value in the resistor, inductor, and capacitor that according to the values that have been given in the lab sheet of activity 6. And firstly, we will connect the AC voltage source in parallel with the RLC load. And these are the components that we will use in the activity 6, which are the V-side for the AC voltage source, resistor, inductor, and capacitor. And next, we will take a one V-side, which is the AC voltage source, and we set the part value to 50 VAC, which is same as the value that has been given in the lab sheet for activity 6. And for the amplitude, we set that to 50 times 1.4142. We set that to 50 times 1.4142. This is because the given voltage 50 is in the RMS value, therefore we need to times with the square root 2 or the 1.4142 to get for the peak voltage or the amplitude. For the frequency, we set that to 50 Hz. And next, we will take the AC ammeter and connect it in series with the AC voltage source. We change the display range to the milliamps for the ammeter. And next, we will take a one resistor and we rotate clockwise and we set the resistor to 390 ohm, which is for the first test in the activity 6. And we will take one inductor and we will rotate clockwise and we set that the inductor to 0.4 H. And next, we will take the capacitor and we change that the capacitor to 2 microfarad. And next, we will connect the resistor, inductor, and also the capacitor in parallel with the AC voltage source. And after that, we will take a one AC voltmeter and we also connect in parallel with the RLC load, which is to measure the voltage that will flow across the parallel of the RLC load. Since that the inductor will act as the short circuit in the DC bias or in the steady state, and therefore we need to add one resistor which is in the series with the inductor to complete for the parallel RLC load circuit. We connected in series with the inductor, we set the resistor to 1 ohm. And next, we can run the simulation and we can observe the value for the ammeter and the voltmeter. For the current we get is 386 milliampere, but for the voltage we get is 50 volt. And next, we can stop the simulation and we can go to the second test, which is change the resistor to 470 ohm for the second test that has been given in the lab sheet. And we run the simulation and we can observe for the current is 379 milliampere, while for the voltage is 50 volt. From the simulation, we can observe that the voltmeter shows that it's 50 volt, which is same as the AC voltage source. This is because the voltmeter is in the parallel with the AC voltage source. Therefore, the parallel arrangements means that the voltage is in the same value, which is in the 50 volt. Besides of the simulated value from the simulation, we can also using the manual calculation to calculate for the current and the voltage. Firstly, we can calculate the total impedance in the parallel RLC load. And next, we can using the Ohm's law, which is V equals to IR to get for the I that will flow through the parallel RLC load. And from the simulated value and the calculated value, we can observe that the value is almost the same, only the slightly different in the current value. This is due to the inductor, it will act as a short circuit in the DC bias or the steady state, and therefore we need to add a resistor in series with the inductor in this circuit. And after that, we can repeat the step or procedures to continue for the other tests in the activity 6. Thank you. And this is a presentation of the simulation for activity 1 to activity 6 in exercise 8 from our group. Thank you.